In this video, I will show you how to solve rational equations such as these. The key to solving rational equations is you form like denominators and then you get to cross the denominators out. So the only denominator I see right now is y. So I need all of the terms to have the same denominator. So I need this to have a denominator of y. But that will only be legal if I also multiply the numerator by y. I also need this to have a denominator of y, so I'll have to put a y in the numerator as well. Once you have those like denominators, you can still have a valid equation if you cross them out. Okay, so that's going to leave me with y squared plus 6 is equal to 5y. Subtracting 5y from both sides leaves me with y squared minus 5y plus 6 is equal to 0. So this is probably factorable. Y squared factors as y times y. 6 factors either as 2 times 3 or 1 times 6. Alright, if I pick 2 times 3, I think to myself inner plus outer must equal middle, so that's 2y inner and 3y outer. In order to make negative 5, both of these would have to be negative. So that makes both of these negative. But then I have to check one more thing. I need to get a positive 6. Negative 2 times negative 3 is positive 6. So this is the correct choice. Once you have it factored, you can set each of the factors equal to 0. So you set y minus 2 equal to 0, and you set y minus 3 equal to 0. So this is going to give me y is equal to 2, and y is equal to 3. Do a quick check looking back to make sure that neither of these solutions are extraneous solutions, meaning we can't divide by 0. So if either of these values will cause a 0 denominator, they are essentially illegal. But the only denominator is y. So that just means that y cannot equal 0. And neither of these are 0, so we're okay. For problem number 2, very similar. I need like denominators. I see the z, so I'm going to need a z denominator. So that means I'll have to multiply the numerator times z. I'm not sure why I put a little 1 on it. Okay, I need a z denominator here, so I'm going to have to put a z in the numerator. Once I have those like denominators, I can cross them out. So that's going to leave me with 8 minus z squared is equal to 4z. Okay, so I'm going to subtract 8 from both sides, and I'm going to add z squared to both sides. So that's going to give me 0 is equal to z squared plus 4z minus 8. So hopefully this will factor. This does not factor. Z squared factors as z times z. 8 is either going to be 2 times 4 or 1 times 8. Say if I do 2 times 4. Inner, I have 2z. Outer, I have 4z. All I can do is control the signs. There's no way I'm going to get a positive 4z out of this. And it's just as bad if I try 1 and 8. All right, there's no way I'm going to get a 4z out of that. So this is unfactorable. So I have two choices. I can either complete the square or I can use the quadratic formula. I think for this problem, I'm going to show you both methods. Now, I'm more comfortable with the equals 0 on the right-hand side, so I hope you don't mind if I just move this over to the right-hand side. So first, I'm going to show you completing the square. Okay, so everything I do next is going to be called completing the square. I'm not sure there's supposed to be an E in there. So here's how completing the square works. Take this constant and move it to the other side of the equation. So that's going to leave me with z squared plus 4z. Leave a space here, and that will be equal to 8. Now, once I complete the square, this is going to be a trinomial, 3 terms. And that trinomial can be written as a binomial squared, 2 terms. Now, I already know what the binomial will be. It'll be z plus 2. I got the 2 just by doing half of 4z. Just do half. Now it's time to complete the square, meaning fill in the 3rd term. Well, if I ignore the z, I have 2 squared. That's what goes right here, 4. Because if I add 4 on the left-hand side, to keep the equation valid, I have to add 4 on the right-hand side. So now I have 12 on the right. To solve this equation, I just need to take the square root of both sides. Don't forget your plus or minus. So this is going to give me z plus 2 is equal to plus or minus. Now 12 is the square root of 4 times the square root of 3. So this will allow me to simplify, because the square root of 4 is 2. So that means I have z plus 2 is equal to plus or minus 2 radical 3. And finally, I am going to subtract 2 from both sides. And this goes right in the front. So I'm going to end up with z is equal to negative 2 plus or minus 2 radical 3. So this would be the final answer. Now I'm going to go back and do the same thing again using the quadratic formula. The quadratic formula says when you have a quadratic equation like this one, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1, and b is 4, and c is also 4. No, I was already completing the square. I apologize. Let me just undo that real quick. A is 1, B is 4, C is negative 8. This is the equation that we're solving. Okay? So that means x will equal the opposite of b, so that'll be negative 4, plus or minus the square root of b squared, so that'll be 16, minus 4 times a, well that's 1, so I don't need to write that down, times c, which is negative 8. Okay, all over 2a, well 2 times 1 is just 2. Okay, so I just need to simplify this now. So negative 4 plus or minus the square root of 16. Let's see. Negative 4 times negative 8 is positive 32. All right, and that's going to give me negative 4 plus or minus 48 over 2. Now, let's see, how much room do I have? Okay, so this is going to give me negative 4 plus or minus. Now, 48 is 16 times 3. So this is the square root of 16 times the square root of 3. And the square root of 16 is 4. So I have x is equal to negative 4 plus or minus 4 radical 3 all over 2. All right, now both of these are divisible by 2. So if I divide everything by 2, that's going to give me x is equal to negative 2 plus or minus 2 root 3. And that would be the final answer. So let's see, negative 2 plus or minus 2 root 3. And then if I look back at completing the square, negative 2 plus or minus 2 root 3. I personally prefer completing the square as long as if I have an even number in the middle, and especially if the leading coefficient is 1, then completing the squares is very easy, and I think it's easier than the quadratic formula. But anyway, do what you prefer. Do you? All right, for number 3, again, the key is having like denominators. Now, I'm going to take an extra step that's optional. I'm just going to spread these out so I have more room to show you what's happening. So I have x minus 1 over 2x minus 4. I could factor out the 2. On this particular problem, that wouldn't make anything any easier, so I'm not going to do that. But sometimes you need to factor this to see if you have the same thing already there. Maybe that'll show up on another problem. Okay, I just spread things out a little bit so you can better see what I'm about to do. So look at the denominators that I have. I have 2x minus 4 and I have 3x. Okay, all of these terms need to have that same denominator. So look, first of all, the first term needs a 3x. So I can put a 3x in the denominator. Okay, 3x. Now this is a monomial, so later I'm going to end up doing the distributive property. Anyway, the next denominator needs a 2x minus 4. So I can put a 2x minus 4 in the numerator and the denominator. Okay, now the next term needs both of these. It needs a 3x and a 2x minus 4. Okay, once you have like denominators, you can cross them out. Okay, so I can go ahead and cross out all of these denominators. So that is going to leave me with, and like I said, I'm going to do a little distributive property here. So 3x times x, that's 3x squared minus 3x. That's what I get from that. And these, I need to like double distribute or FOIL, whatever you want to call it. X times 2x, that is 2x squared. Okay, inner I have 4x. Outer I have negative 4x. Interesting. I have 4x and negative 4x. So those will cancel each other out. But then I have 2 times negative 4 is negative 8. Okay, over here I'm going to distribute again. So that's going to give me 6x squared minus 12x. Okay, I have like terms here and here. So I'm going to put those together now. So that's going to give me 5x squared minus 3x minus 8 is equal to 6x squared minus 12x. Now I need to get these on one side of the equation, so either I'm going to move these three to the right or I'm going to move these to the left. The reason why I'm going to move the 5x squared is because I really want the x squared term to be positive. So if I do it this way, it'll be positive. So then I would add 3x to both sides, and I would add 8 to both sides. Okay, let's see what I get. So now I have 0 on one side of the equation, and then over here I have x squared minus 9x, okay, those make negative 9, plus 8. Okay, so hopefully this is factorable. X squared is x times x. 8 is either 2 times 4 or 8 times 1. So that means inner I have 8x, outer I have 1x. I'm trying to get negative 9. That will happen if both of these are negative. So that means both of these would have to be negative. And a negative times a negative is a positive. So that works for giving me positive 8 as well. So this is the correct factorization. So now I set each of these equal to 0. So x minus 8 equals 0, x minus 1 equals 0. Therefore, x is equal to 8, and x is equal to 1. Before I declare victory, I just need to glance back at my denominators. Make sure that none of these are extraneous or illegal. None of these, neither 8 nor 1, would cause a 0 denominator. So these are both valid. So I have two solutions, x equals 8 and x equals 1. All right, so that was problem number 3. All right, problem number 4 has this one extra little weird step to it that I have to deal with. Can you see how this is backwards? We need to fix that. And so look, if I have 2 minus y, if I reverse the order of these terms, that would be negative y plus 2. But I can take out the negative 1 outside of parentheses, and that would make it negative y minus 2. So that means that 2 minus y is the same thing as negative parentheses y minus 2. So that is what it takes to transform this in such a way that I can compare apples to apples. Because when I'm factoring later, like I'm looking at the y squared minus 4, can you see that's going to be y plus 2, y minus 2? I need to see that I already have a y minus 2. So I don't want to treat the 2 minus y as being completely different from y minus 2, because they're not. Okay, so that's why I'm doing this. So I'm going to go ahead and rewrite these more spread out so I have more room, but I'm going to make this substitution. So let's see, I have 2 over y plus 2. All right, and I'm leaving a little bit of space. And then I have negative y over, okay, and this is negative y minus 2. Okay? I see I've got a minus negative here. I'm going to come back to that in a second. Interesting. But anyway, for now, I'm going to keep going. And here I've got y squared plus 4. Please notice this is unfactorable. But y squared minus 4 is factorable. In fact, I'm going to go ahead and factor it as y plus 2, y minus 2. Alright, so everything I've just written is equivalent to what we had. Now I want to make one more change. When you do minus a negative, it's a positive. So really this is a positive. Okay, now we can do the rest of the problem as usual. You know that we need like denominators. So I have a y plus 2, but this one has a y minus 2. So I'm going to give it a y minus 2 in the numerator and the denominator. This one has a y minus 2. It needs a y plus 2. So I'm going to give it a y plus 2 in the numerator and the denominator. This one already has both a y plus 2 and a y minus 2. So I don't need to give this one anything. Okay? So now I can cancel out the denominators. So that is going to leave me with all of this. Now I'm going to go ahead and do the distributive property. So that's going to give me 2y minus 4 plus, I'll do the distributive property here, that's going to give me y squared plus 2y is equal to y squared plus 4. So let's do like terms next. I see that we have 2y and 2y. Okay, I guess that's it for like terms. So that's going to give me y squared. Now 2y and 2y make 4y. And then there's minus 4 equals y squared plus 4. So next I want to subtract y squared from both sides, because I want to get these together. And I'm also going to subtract 4 from both sides. Okay, so that's going to give me, well, these cancel out. So now I have 4y minus 8 is equal to 0. So I have a choice. I could do like a GCF. I could take out the 4, or I could just add 8 to both sides and divide by 2. I think I'll just keep going with having 0 on one side. So if I take out the GCF of 4, that's going to leave behind y minus 2. Okay, and if I set this equal to 0, if I set y minus 2 equal to 0, that's going to give me y equals 2. All right, 4 cannot equal 0, so that's not going to give me anything. I'm disregarding that. But wait a minute. Now I need to look back and check and make sure this is not extraneous. I need to make sure this would not cause a 0 denominator. Problem is, it does cause a 0 denominator. Okay, right here. If y is allowed to be 2, then I have 2 minus 2. That's 0. Also right here, if y is 2, then 2 squared is 4. That's 4 minus 4, that's 0. So this is extraneous. It's an illegal value. So I have to throw it out. But wait, that was my only solution, and I just had to throw it out. So what does that mean? That means no solution. Pretty tricky. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.